Welcome. In this video, we are going to discuss regular expression optimization techniques. We'll explore methods to make your regular expression patterns faster and more efficient. Performance truly matters when processing large datasets, so optimizing your regular expressions can significantly reduce processing time. Let's understand why optimization matters. Inefficient regular expressions can lead to catastrophic backtracking and exponential execution time, which slows down your application significantly. Optimized patterns can drastically reduce processing time, potentially cutting down execution time from minutes to just milliseconds. One of the key challenges in regular expression performance is catastrophic backtracking. Consider the problematic pattern. Open parenthesis, a plus close parenthesis, plus b. When matching fails, nested quantifiers like these can create exponential complexity. For example, an input string like a repeated many times followed by x can cause a massive amount of backtracking as the Regex engine tries every possible combination. Anchoring is a technique to greatly improve performance. Start and end anchors can prevent unnecessary searching. Take a look at the slow regular expression email.star@symbol.star/.com. Now consider this fast regular expression open bracket at symbol close bracket plus at symbol open bracket at symbol close bracket plus \.com $. The fast one is much more efficient because it precisely defines the start and end of the string, avoiding unnecessary searches throughout the text. Being specific with character classes can avoid unnecessary matching attempts. Look at the inefficient regular expression .phone. This matches everything greedily. In contrast, the efficient version is open bracket a to z 0 to 9 \s close bracket star phone open bracket a to z 0 to 9 \s close bracket star. This only matches relevant characters within the specified character classes, leading to faster and more accurate results. Atomic groups and possessive quantifiers are advanced techniques to prevent backtracking once a match is made. For example, an atomic group looks like this: open parenthesis greater than a plus close parenthesis b. It prevents backtracking within the group. A possessive quantifier looks like this: a plus b, and it consumes all matches greedily, ensuring the engine does not backtrack to try alternative matches. Non-capturing groups reduce memory overhead when you don't need to store the matched groups. Here's an example of a capturing group: open parenthesis https / close parenthesis open parenthesis dot plus close parenthesis. This stores matches in memory. Now check out the non-capturing group: open parenthesis https / close parenthesis open parenthesis dot plus close parenthesis. It's faster and uses less memory because it doesn't store the matched group. Use non-capturing groups when you only need to group parts of the regex without needing to recall the matched text. Choosing the right matching strategy between lazy and greedy quantifiers is very important. The greedy quantifier, represented by an asterisk like in the regular expression less than greater than, matches as much as possible, which can cause overmatching. The lazy quantifier, represented by an asterisk followed by a question mark like in the regular expression less than greater than, matches as little as possible, which is more precise and often more efficient. Compiling regular expressions once and reusing them multiple times can significantly boost performance. The inefficient approach looks like this: for text in text new line, for spaces re.search open parenthesis r single quote \d plus single quote comma text close parenthesis. This compiles the pattern every iteration. The efficient approach is pattern equals re.compile open parenthesis r single quote \d plus single quote close parenthesis new line, for text in text new line, for spaces pattern dot search open parenthesis text close parenthesis. This compiles the pattern once and reuses it efficiently, so this can lead to significant performance gains, especially in loops. Let's recap the key optimization principles. First, use anchors to limit the search scope. Second, be specific with character classes. Third, avoid nested quantifiers that can lead to catastrophic backtracking. And fourth, compile patterns for reuse. By applying these principles, optimized regular expressions can improve processing speed significantly, often by a factor of 10 to 100 times. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.